All right, I think we're going to get started. Hello, everyone. My name is Katie Kaluzny. I'm the Deputy Director at Illinois Green Alliance. I'd like to welcome you all to the second session of our 2023 Building Decarbonization Tech Series. This series offers an opportunity to explore building technologies and services that are transforming the industry. It's exciting to get a chance to showcase companies on the leading edge with our green building industry members and friends. And today's session is going to highlight clean tech innovations for the building sector coming from our neighbors to the north in Canada. Today's program is being put on by Illinois Green Alliance in conjunction with the Canadian Consulate General. You have all been muted upon entry, so please type any questions that you have into the Q&A and we will get them answered at the end of today's session. This webinar is being recorded and will be sent out in a follow-up email as well. Just a little bit about the Illinois Green Alliance. The Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our strategic plan is pushing the green building industry to meet or get on the path to net zero. And we achieve this work through educational events such as panels and building tours like today, educating and engaging communities and partnering with organizations across Illinois, and advocating for new policies and legislation that support our mission. You can review our recorded webinars in our on-demand webinar library anytime and learn about membership, upcoming events, and getting involved on our website at illinoisgreenalliance.org. I want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, and Sloan. You can make a commitment to advancing green buildings in communities across the state and talk to us about sponsorship today at illinoisgreenalliance.org/sponsorship. I want to give a special thank you to the Canadian Consulate General in Chicago, Minneapolis, and the Embassy in Washington, D.C. for partnering on this program series today. It has been a pleasure to work with Anne, Allie, and Kate to develop this program and find amazing panelists to speak with you today on this topic. I'd like to turn it over to Carl Pilon from the Minneapolis Consulate General to say a few words on behalf of the consulate. Carl?
Thank you for your kind introduction, Katie. Bonjour tout le monde. Hello, everyone. I'm delighted to be joining you this afternoon. We're pleased to host the second of a two-part series, the Building Decarbonization Technology Series, with our valued partner, the Illinois Green Alliance. And I would like to thank the Illinois Green Alliance's Katie Kaluzny and Twyla Neely-Straight, as well as our esteemed moderator, Kate Anderson from Johnson Controls, for their work in putting all of this together. I'm joined, I was about to say this afternoon, but it might not, well, I believe it's afternoon everywhere. Joined this afternoon by my colleagues, Ali Kimlinger from right here, the Consulate General of Canada in Minneapolis, and Rosen from our Consulate General in Chicago. And as Katie was mentioning, Kate Salimi from our embassy in Washington. Our offices in Washington, Minneapolis, and Chicago are part of a network of Canadian diplomatic missions that work to connect businesses and people on both sides of the Canada-US border. I mean, we saw with President Biden's visit last week in Ottawa that this is a relationship that has been fantastic for years and years and years, but that doesn't happen by magic. There's a lot of little people in the background that grease the wheels on a day-to-day basis, and we're part of those. We're some of those people with an in-depth knowledge of global markets and insight on Canadian industry sector capabilities. We can connect you with strategic procurement, investment, innovation, or investment partners in Canada. Canadian companies have demonstrated world-class capabilities in the design and construction of sustainable building projects, along with expertise across diverse climate, geographical, socioeconomic, and environmental conditions in Canada and abroad. We're pleased to have 3 such examples of innovative Canadian technologies reducing energy and carbon from building operations to present to you today: TROES, Carbon X, and Evercloak. I'm looking forward to their presentations and hearing about their solutions in meeting the increasing global demand for more energy efficient buildings. As our nations work toward meeting our Paris Agreement commitments and net zero targets by 2050, we recognize the critical roles of technology, innovation, and investment in enabling global net zero ambitions, And I have to say that I'm always interested when I get the chance to do anything that's related to construction or architecture in the context of this job, because in a previous life, when I was in school, I got a degree in architecture and another one in urban and regional planning, and somehow I landed in the foreign service. So when those two intersect, I'm just like really, really happy. So I'm looking forward to the session today. Thank you all to everybody in our offices, and especially with the Illinois Green Alliance for having put that together. Merci à vous toutes. And I would like to pass it back to Katie. Over to you.
Thank you so much, Carl. I promise this session will make you very happy. And glad that it's combining all of your interests into one webinar today. We're so happy to have you, and as Carl mentioned, have all of our companies joining us today as well, from Evercloak, CleanO2, and TROES. We're going to introduce now our moderator for today's session, Kate Anderson. Kate Anderson is an account executive with Johnson Controls within the HVAC and building automation space. She is an active volunteer with Illinois Green on our programs committee this year, and she's going to be graduating from UIC's Masters of Energy Engineering program this coming May. Kate also happened to have recently won Illinois Green's Outstanding Volunteer of the Year. So she's a great moderator. You're in good hands today, and I'm going to welcome Kate to kick us off. Kate, take it away.
Thanks, Katie. Good afternoon, everyone. It's great to be with you today for the Building Decarb Tech Series with Illinois Green and our partner, the Consulate General of Canada. I'm really looking forward to learning more about these three companies and the inspiring individuals driving innovation and growth of new green tech that'll help us all as we work together to achieve net zero buildings. This series specifically allows us to dig into existing and emerging energy and decarbonization solutions and share how we can spread awareness to incorporate these ideas into more regional buildings and projects. The entrepreneurs you'll hear from today not only will educate us about the new technology, but are here to encourage us to take those bold and courageous steps to implement the exciting clean tech solutions that are out there today and can have a major impact on our sustainability goals. With that, I'd like to thank our three companies, Evercloak, CleanO2, and TROES, for joining our series and sharing their building envelope solutions with our members and partners. To start, I'd like to introduce Evelyn Allen, CEO and co-founder of Evercloak. Evelyn Allen is a pioneer in the clean tech space, leading engineering projects, growing multi-million-dollar technology innovation platforms, and building corporate strategic partners. She's a professional engineer with a master's in environmental engineering. Let's welcome Evelyn and learn more about Evercloak's innovative membrane technology and its application for building projects.
Thanks, Kate, and I guess good afternoon, everybody. I was also wondering if it's morning or afternoon. I'm just going to share my screen here, and please let me know if you have any problem seeing it. Good to go. So again, good afternoon. My name is Evelyn. I'm the CEO and co-founder of Evercloak. And we are an Ontario-based company. We're based out of Waterloo, Ontario. It's about just an hour outside of Toronto. We are an award-winning clean tech startup that leverages advanced materials to solve global environmental challenges. And so in terms of the startup stage, we're pre-revenue, but yet we're commercializing our technology and on the cusp of really getting some exciting pilots and data. And so I'll share some of that with you. In terms of some of the awards that we've won, we were a national winner of a program called Breakthrough Energy Solutions in Canada that was sponsored by the Bill Gates Venture Energy Fund in partnership with the Government of Canada. We've won a series and a variety of other awards in Canada, as well as being innovative clean tech. And again, a spin out from the University of Waterloo. And so just I'll give you a little bit of background about our team and our company, and then I'll go into the problem that we're solving in our technology and our solution. Kate gave an introduction to myself, again, an engineering background, but really moved into this role at Evercloak because I wanted to make a difference and make an impact. And I had an opportunity to secure some funding to help leverage and grow Evercloak. And so initially when we started, we did not have a product market fit really, or even really a commercial technology. So it's been a really great process to be part of to get to the stage we're at. My co-founder, Dr. Michael Pope, is just here beside me, and he's a faculty member at Waterloo. So he did his PhD at Princeton and has worked in the nanospace for a long time. We also have others on our team that bring a lot of commercialization experience. Ted Mao, coming from Trojan Technologies, which is one of the larger clean tech companies in Canada, and a Danaher subsidiary. Matt Hoof just recently joined our team from Xerox. He was leading the Canadian Research Services research business out of Mississauga, and Anna Zialecki, who runs our operations. And our team is supported through a very strong advisory board. And so just some of the names from this advisory board: Xerox, Ashish Kulkarni comes from Carrier, so has an understanding of HVAC, but also how materials can be integrated into new products. We have Chen Ogilvy, who worked with Rockwool, brings a lot of strategic and sales acumen to our team, and Wayne Madiver, who's the lead for our current funding round. And so maybe with that, just a high level overview of our company, but really wanted to talk about one of the problems that we see, and it is a growing concern today. And I think that you could say really preaching to the choir, but I think everyone on this call understands the challenge and the importance of reducing our carbon footprint when it comes to buildings. And if you look at some of this is a little bit dated, this article, but it's still valid today, that by 2050, building cooling is going to represent 30% of the world's electricity use. And so what I like to say is, in Canada, when it gets really hot and uncomfortable, we are fortunate that we can go inside and turn on the air conditioning. And that's what millions and millions of more people are going to be doing across the world as the world warms up, and as more people have access to income and to a living wage income. And so this is going to have a huge impact on our climate unless we do something different. So at EverQuote, we have a solution to help. It's a proprietary membrane dehumidification technology that can reduce the energy use of building cooling by over 50%. So our technology touches on several of the Sustainable Development Goals, including climate action. And so through our proposal to Breakthrough Energy Solutions program, we had to demonstrate a clear, viable path to reaching 0.5 gigatons reduction per year. And so we were able to do that. And if you're new to kind of this metric, this gigaton per year, 0.6 gigatons is equivalent of removing all the cars off the road in the US and Canada for an entire year. So it's a significant piece of the greenhouse gas contribution. So how does this work? Well, if you think of today's cooling technology using vapor compression, it removes the humidity from the room and cools the air temperature in one step in the same process. And so you condense the humidity, it removes that humidity, which is the latent heat, it drops the temperature in that process, and often it's below comfortable, especially in very humid climates. And so then more energy is needed to heat that back up. And so what we do at EverQuote is we kind of separate that process. We're able to remove the humidity ahead of the cooling system and decouple it from that air temperature. And so if you see here, this is our dehumidification technology. The hot, humid air flows across our membrane. And so our membrane is our enabling technology and the core technology at EverQuote. What our membrane is able to do is essentially separate out the water vapor very quickly from the air. And I can talk a bit more about the technology itself, but we're able to essentially pull the moisture from the air while allowing the dry air to continue on. And so I like to say our membrane is an open door to water vapor and a closed door to gas or air. And as a result of decoupling the humidity from the cooling system, we're able to, that cooling system can be sized smaller, use less refrigerant, have less OPEX and CAPEX, giving an opportunity for more efficient buildings and more efficient building cooling. And our technology can stand alone or it can be integrated into cooling technology. And I'll talk a little bit more about the stage we're at and explore that in a little bit. So in terms of the markets that we're targeting with our technology, it's the global cooling and ventilation equipment market. It's a huge market, but to start and to de-risk our technology and our commercialization path, what we've done is separated our business model into two prongs. The first prong is us manufacturing and selling our flat sheet membranes. And so that's, again, our core enabling technology. There are a few technologies today that already use membranes. For example, energy recovery ventilators. Most of you may be familiar with these. Essentially, as it's a ventilation system, and as indoor air comes in and outdoor air goes in, it's an exchange system. It's similar to a heat recovery, but in addition to recovering heat, you're also recovering moisture. And so the membranes that are being used today, they work, but our membranes work better. And so we're now sampling and validating our membranes for this use case to enable ERVs to work better and save more energy. At the same time, we're working with other partners in the cooling space that are looking at membranes and integrating membranes into new products. So for example, cooling tower. We're working with a group that's looking at doing membrane-based cooling towers. And so there are opportunities for better membranes or membranes that today are too expensive or don't have the performance to be able to meet these type of new products. And so again, selling our membranes into these markets so that we can scale up our membrane manufacturing, drive down costs, get to revenue, and support growth there. But at the same time, we have a large funding-based support, non-dilutive funding, so from grants, to take our membrane and integrate it further down the value chain into cartridges and modules to validate and show the energy efficiency of removing that humidity ahead of a cooling system, so dehumidification. And that's our second prong approach. And so again, we're scaling up our membrane manufacturing, looking to sell flat sheet membranes to those who want better membranes to get to revenue quickly and to add value to their industry. But at the same time, growing towards the system sales and systems for dehumidification. And so I'll show you a little bit about what these look like. And this is a slide, talked a little bit about this already, but this is an ERV and what this looks like. So these are stacks of membranes right now. And we've pulled apart commercial membranes and tested them head to head. And our membrane has a 4x better performance than several of the membranes we tested. And what that means is our membrane can be more efficient. So if you install an ERV, say to your residential home, you can save 30% of energy on your air conditioning cost. If you install the same ERV with Evercloak membranes, you can save an additional 20%. So there's an incremental increase in energy savings with a better performing membrane. But we're also finding that the ERV manufacturers are interested in the stability of our membrane. It doesn't rip or tear, it's easier to manufacture, which will enable them to integrate and launch products that will allow them to bring this technology to commercial and industrial applications as well. Where we've heard is that membrane is a limiting piece in terms of how functional it is at a larger scale. And then again, I mentioned the cooling tower technologies. We're also looking at working with liquid desiccant. So you may have heard of liquid desiccant dehumidification technologies. And while this may compete with our other technology, the dehumidification, these technologies also are saving energy and need membranes. And so we've been able to show that our membrane can work very well for these applications as well. So that fits in with our first business model. So why is our membrane so great? And this is just an example of kind of the scale up that we've done in the last few years. So when we first started, we had the hypothesis that this would work. We're using a material called graphene oxide. It was demonstrated in 2012 that it has the highest rate of essentially allowing water to go through it than any other material while being airtight essentially. And so it's a really unique property. And the reason it's people are very excited about it, but one of the reasons it hasn't gotten to commercial scale is the scalability of it. And so our core technology is around making low cost, large area membranes to commercialize and unlock a lot of these potential applications of this material. And so this is a picture of us scaling up our production on a commercial roll-to-roll coater. The yellow is the graphene material, and we put it on a support material to give it some structure. And again, in terms of how this compares or competes to other materials, right now we have over 2x performance in how quickly the water goes through. And so that means we need much less membrane. And so ultimately, as we get better and better performance, which we are seeing really amazing results in the lab at this end, we've kind of frozen the design here as for its initial product launch. But as we even further increase the performance of our membrane, you'll need less and less material to achieve the same thing. So that means your system is sized, a 10th, a 20th% of what you could do today with the materials on the market today. And so this is our dehumidification unit. I mentioned we are working to sell flat sheet membranes as above, but we also have a significant amount of funding to build out and validate the dehumidification technology. And so we just recently installed 2 of these units. So we're really excited. We've been working on this for over a year into the city of Kitchener's facility. So they have a warehouse that they've allowed us to pilot our technology in. And we've received funding to do this from Canada. Has a program called, used to be called Built in Canada, but essentially it's a procurement program for new innovations. And so, and to demonstrate and to help validate new innovations. And so this pilot is installed. It's built as a test unit. We have different pressure sensors, humidity, temperature sensors, energy sensors. This here is a built-in HMI, so an interface where we can monitor and track all of the different data that we're collecting. And it's also being reported back to us regularly as well. And so We installed this again 3 weeks ago. We're really excited. We've been able to demonstrate that it works. So we are seeing humidity reduction. It wasn't designed yet to be energy efficient. It was really the purpose to validate this approach of using membranes and help us calibrate the performance of our membrane material. And so as part of scaling this up, we've designed and put patents around our cartridges. And as you can see, it's really the membrane that's the enabling piece here, our graphene composite membrane. But really excited about this. And my colleague Rowan is on the call, and I won't be here for the Q&A, but he'll be here and he can answer any questions on this as well. But we are seeing good humidity reduction results with this. And the next step for this is to, we can't announce publicly yet, but we have heard that we have received or will be receiving a significant amount of funding from a US state to focus on the next phase, which is building this system to be more energy efficient. And so again, we have the humid air that goes across our membrane. We're pulling the vapor through a membrane with a partial pressure difference. And so we have it's almost like osmosis. You either need a dry air on one side, or you need to create that. And we do that with right now just a vacuum, but we have path and model to reconfigure that drawing system to enable that energy efficiency. And one unique aspect of our membrane as well is, if you think of vapor compression, one of the challenges is doing dehumidification in cold environments. And so what we've seen so far is that we've had very good performance still at a very, very low temperature. So that's another interesting piece of our material. But again, we're at the early stages, we're validating, we're collecting data, we're understanding where this might fit in the HVAC space, what our go-to-market strategy is. We have been working on that and have ideas on that. But again, this is prong 2, and that's kind of what we're doing over the next year, is to really build out that business model. And I know a lot of you here on the call have a lot of experience. I come from a water technology space, so not the building space. So would love to hear from anybody on the call or connect with anybody who has ideas on where this could help and what the pain points are additionally in your pace. So this is, again, really early data. Our first week, it's sometimes I don't even want to, we have to validate, we have to do more testing, we have to figure out the operating parameters more, but this is just kind of demonstrating that we are removing humidity with our system. The blue is incoming, the light blue is outgoing humidity. So the difference is the humidity we're removing, and we're looking at different temperatures. And so one thing, I didn't put it in here, but I can also share this with you. We built one of our funds, we received a $4.6 million grant with a partner out of Ontario, an HVAC partner, and they've helped us build a large testing unit that mimics all of the environmental conditions we need to validate our material and how it operates. And so we're able to operate at up to 500 and we're up to 500 CFM. Our units that we've built are modular. So this is a small unit we're just doing for testing, but we have built these larger 1 foot by 1 foot units. These are modular, can be added 2 or 3 or 4 to get the right CFM that you need. And we are testing those for pressure drop for different temperatures, humidity, types of airflow, whether it's turbulent or not, and really excited to see some more results and be able to calibrate the performance of our material and our membrane and how it works. And so I get a lot of questions around energy savings, and we've been working with National Renewable Energy Lab out of the US, out of Denver, Colorado. They have a building sciences group with a really well-known researcher, Jason Woods, in this space of dehumidification. And he just recently published a report called Humidity's Impact on Greenhouse Gas Emissions. So if you're interested, you can take a look. But there it shows vapor compression, the efficiency of that today, and the potential of separation of water from air. And so while the vapor compression moisture removal efficiency today of technologies is, this is quite high, actually, it's closer to 2.6. If we can get to even 30% of what's possible with this type of technology, then we see almost a 10x improvement on the energy efficiency of vapor compression. And so we are in our current plans just reaching that same level of vapor compression, but as we optimize our system, we'll be looking to increase that further. This is a really busy slide. You don't need to read it. I guess the point of this is that we're actively doing customer discovery, and we would love to hear if you're one of these customer segment users. If you have pains or needs or areas where you think a technology like this would have a big impact, please let me know. I'd love to chat with you. We are putting together work groups to do some of this activity, and again, would love to hear more of this. But as I mentioned, some of the key pieces that we see is refrigerant-free, low maintenance, easy to install, modular, And what we're looking at building over the next, as we build up the business model and work to identify the best form factor of this technology, whether it's a retrofit kit that can be installed in existing building base to give more capacity to existing HVAC, rather than upgrading your HVAC to meet the rising temperatures in all of our communities and cities. But we also see a huge impact for spaces that use a lot of dehumidification. So for example, labs, clean rooms, pharmaceutical manufacturing, where there's not a lot of recirculation and it's a lot of intake air. And so that's what we're also really excited about, but those systems are a bit bigger and more complex. And so again, trying to figure out the best path and entry to market for this technology at this stage, while we ramp up our membrane manufacturing for that. In terms of traction, we are selling, we've been sampling membranes with manufacturers. We're getting really good testing on our material for different things like fire rating, strength, freeze thaw, air tightness, even wash cycles. We have 2 of these smaller pilots and a larger pilot built right now that we're testing, and we have some paid feasibility studies for this technology in the defense space. We've raised some investment money. We're actively doing a seed round, so as well, if anybody knows of any investors that may be interested in speaking with us, I'd love to hear. And a lot of non-dilutive grant funding. We have IP across a spectrum of our materials, our membranes, our cartridges, and our systems. And I'm just getting to the end of my time here, and I just wanted to end on this partner side. So I would love to speak to anybody and learn more about your pain points and how we can help. So thank you very much, and look forward to hearing from you.
Thanks, Evelyn. Everyone, please continue to add your questions in the chat for Evelyn and EverQuote, and we'll address them in a bit. Next, I'd like to introduce Warren Brook, Chief Technology Officer of CleanO2. Warren is a mechanical engineer with 15 years of experience in sustainable buildings and greenhouse gas management. He's worked to mitigate GHG emissions through energy modeling for LEED projects, monetizing emission reductions through carbon offset project development, design and implementation of government climate programs, and design and performance evaluation of small-scale carbon capture machines with CleanO2. Let's welcome Warren to share more about CleanO2 and their CarbonX technology application for existing buildings.
Hi, everybody. Can you hear me?
Yes.
Great. That was great, Evelyn. I think I need to talk to you about dehumidification after hearing your speech. We're kind of on the opposite end of your technology. So CleanO2, we are carbon capture technology specifically with respect to commercial building heating systems. We do carbon capture after combustion, and we do nice, clean circular stuff with it after we capture that carbon dioxide. We have a patented microscale carbon capture system specifically for natural gas heating. And the reason we do that, most buildings in Canada and the United States, they are attached to the natural gas heating grid for heating fuel, and it's nice and energy dense, and all that infrastructure already exists. So we were coming at it from what do existing buildings, what options do they have for greenhouse gas reductions? We want to do environmentally friendly products after we capture that carbon dioxide. And that, we think, will accelerate the transition to a circular lifestyle. So doing better and also converting what we don't want into things that we do want. So there it is. There's our black box. This is what we call our CarbonX machine. And this is a nice, tidy little package that sits right next to your heating boiler in your commercial building, in your mechanical room. And then we just sip a little bit of the exhaust stream off of the chimney and pass it through a reaction chamber. The reaction chamber is filled with potassium hydroxide. And that chemical has a real affinity for carbon dioxide molecules. And it binds to that, binds chemically and produces the salt of potassium, so potassium carbonate. So we're kind of doing a mineralization process. We have been up and running commercially since about 2017. So our very, very first machine went into a multi-unit residential building here in Calgary. And yeah, it's been running ever since. We are UL certified and National Sanitation Foundation approved. We're technically considered a, what do you call it? Economizer. That's what it is. So the UL listing we have is for economizers on exhaust streams. And that makes our machine pretty easy to install into a mechanical building or a mechanical room. Since the listing is basically for existing economizer components. So the building owner only has to purchase, only has to have the upfront purchase cost of the machine, and then CleanO2, we make our money off of the recurring revenue from going into the mechanical room and recovering the carbonate. So we make value-added products out of the recovered material, and that means there's no ongoing cost of ownership for the building owner. And we can offer a pretty reasonable return on investment of about 5 years. So some of the things that we're targeting, about 8 tons of carbon dioxide reductions in a building, and 8 tons might not seem like a lot compared to the problem of global climate change, but in a building, actually, it's quite a bit. So we say 20% plus. And then I'm working on a version right now. We're sending version 3s out to the field right now. The next version, version 4, next generation, we're targeting 50% plus carbon dioxide reduction, and it will be compatible with condensing appliances. So we know the heating industry is going to more efficient condensing heating appliances, and we really want to attach to those types of machines, but it takes a little bit more engineering to make them talk the right way to the boiler that we're attached to. And another thing that people often ask is this CO2 permanently sequestered in the carbonates? And the answer is yes. So potassium carbonate has a pretty good bond with the carbon dioxide molecule. And when we make value-added products, there's only 2 things that can make the potassium carbonate release the CO2 again as a gas. And that's if it's hit with high temperatures, like 900 degrees Celsius kind of temperatures, like in a kiln, or if it's hit with a high acid. So what we do with it is we make soaps and detergent products. And when you wash with the soap, the potassium carbonate component just goes down the drain, just like it would if it was table salt, for example, or sugar dissolving in water. Just there's no real risk with table salt of chlorine gas coming out of solution. The same is true with potassium carbonate. The CO2 just stays in solution with the potassium ions. Now, how do I click over? All right. So this is a fun little animation we put together. So in all the commercial buildings, there will be some heating plant somewhere buried in the basement of the building. So you have a natural gas boiler. We have fuel coming in and exhaust coming out. And ordinarily, the exhaust just leaves the building through the chimney stack. And we have cold water coming into the boiler, and we have fire and warm water leaving. So the building will have some return at a lower temperature than the hot water supply. And that is achieved with combusting a fuel. But we have carbon dioxide and waste heat going up the chimney, and we want to reduce that. So what we do is we put our Carbonex machine next to your boiler, and we take a little bit of the flue gases, pass it through our machine. So the hot flue gases and carbon dioxide coming into our machine. And then we return with the aid of a fan back to the existing chimney less heat and carbon dioxide, and we recover that heat for doing useful things in the building. And the thing that we do is recover heat, so we can take some load off of that boiler or do something else in the building that's useful. So a lot of the time what we do is preheat the municipal water supply that's on its way to the domestic hot water in the building. Or if you have something else like a swimming pool, we can always dump the heat in the swimming pool, or even just a fan coil unit in your building, somewhere in a room that you want to heat. So this is just saying we reduce the water temperature differential, so the boiler has to do less work, has to burn less fuel to maintain its temperature in the building than what comes out of the machine. So this is interesting. We put potassium hydroxide flakes into the machine, and then what comes out is this mineral called potassium carbonate. There's all sorts of uses for this potassium carbonate. What we do is we make soap out of it and detergents, chemical cleaners, but in the future, industry, they use it for textiles and fertilizers and fire suppression, all sorts of stuff. So why do we use ProLash in soap? ProLash has strong cleaning power, adds a really luxurious silky feel to the soap, and it acts as a water softener. So all these three things make it really good for soap. And actually, another good thing is that the soap is a nice small package that it's easy to participate in carbon reduction, so you can buy some soap that you use in your showers and in your home, and it's something that goes along with buildings like hotels. Hotels have lots of soap demand and also lots of heating demand. So this turning your waste product, your greenhouse gas emissions into soap, plays really well in lots and lots of different building types. Yes, and it's used as a fire suppressant in some applications. So very kind of safe to have in your mechanical room. We've been building out relationships across North America, and in the United States specifically, we have good relationships with Centerpoint Energy and Northwest Natural. We're developing relationships with Vermont Gas and Peoples Gas. So we're making inroads, and certainly across Canada we are too. So across Canada, we started out with ATCO here in our home province of Alberta, and Fortis BC and Fortis Ontario, and Enbridge in Ontario. Enbridge is a natural gas pipeline company, but they're also a retailer, and Sask Energy in Saskatchewan. And one of our very first interested parties was Tokyo Gas. So Tokyo Gas has a big laboratory facility in Tokyo, and they bought 6 of our machines just to test them to destruction. And they've been pretty impressed, and now they're working on their own relationships with their big customers to install these carbon capture machines in their service region. And some of the larger building owners in Canada, Cadillac Fairview, they do shopping malls. Oxford, they do big office towers, and Triovest, they also do office towers. So these are commercial property partners that we're working with very closely, and the Gas Technologies Institute down in Illinois. So we've been working with them quite closely, and they have one of our units in their laboratory, and they're just starting to run it now. So we're very happy with that relationship. And then some of our governmental partnerships as well. So NAV, FAC, Naval Facilities Engineering Systems and Command, big mouthful. The Export Development Canada, Sustainable Development, Technology Canada, all sorts. So Trade Commission of Canada, and now Illinois Green Alliance, yay. And that's it. I guess we're trying to save the world and doing it one mechanical room at a time. Happy to have any questions. How do I stop sharing my screen?
Thanks, Warren.
How do
As
I
Warren-
stop sharing. There we go. All right.
Great. So please, everybody, please be sure to add your questions to the chat for CleanO2, and we'll get to them after our final presentation. So finally, I'd like to introduce Dennis, co-founder and CFO of TROES, that stands for the Revolution of Energy Storage. Dennis has been with TROES since its beginning in 2018 as CFO and SVP Corporate Development. Dennis has a background that includes more than 10 years in each of embedded systems engineering, capital markets, and startups. In his prior role, Dennis led the turnaround and ultimate sale for $55 million of a software company in Austin, Texas. He's a professional engineer and also has an MBA. Dennis is going to share more about how TROES is addressing energy storage solutions in small and mid-scale applications. Take it away, Dennis.
Thank you very much. Sorry, I went to echo at the end. Good afternoon, everybody. Thank you for attending, and I pity you for having to listen to my voice after these other presenters. But anyway, given that this is Illinois, I thought I'd just point out on our cover slide here that this system that I'm circling with my mouse, I hope you can see my mouse, it's in the center of the screen. That's actually sitting right at the University of Illinois at Carbondale, outside their main engineering building. And it's used for tied to a solar system that's on the roof of the building. That's part of their decarbonization efforts. So what is TROES? Let's just try to get things working. So what do? We make energy storage systems, and we configure them into what we call a microgrid. And I'll get into a little bit of what a microgrid is. And we bring these to the commercial industrial space to help them participate in the transition to what we call the new energy of the 21st century. There are really three big markets, if you look at it as markets: the utility, the residential, and then the commercial industrial. The commercial industrial really hasn't had a lot of good products and good choices to get on board with this. There's lots of products in the utility and home space for energy storage systems in particular, which is our part of this. And so that's where we focus. And just what is that transition? I think everybody in this call probably knows this, but we've had a centralized grid for roughly 125 years, where you have large generating plants, you have long wires through lots of different products that ultimately deliver the power down to the end users. It's prone to shortages, blackouts, and it's also very hard to connect onto that grid if you're not already there. It's very expensive to run wires into a new neighborhood and so on. As we go forward in the 21st century, we're going to see things evolve so that we become an interconnected series of microgrids, and microgrids will include their own generation. Could be wind, could be solar, could be biomass, could be a combination of all of those, could even be a carbon-based generation as a backup system. So that these microgrids will ultimately share power amongst themselves and net, and so you'll reduce the need for the centralized grid and those central power plants. The benefit of all of this is that you'll have a lower cost, cleaner and more accessible grid. And so this really fits into the big picture of the electrification of everything, the decarbonization of everything, and the digitalization of everything. The digitalization being everything, almost every device now has an internet address, so it enables a lot of new solutions that weren't available before. So where do we fit into this microgrid? This is where we focus. In the microgrid, there are four key components. There is some kind of load on the microgrid. Could be a single thing, could be multiple buildings. There's a generation of some form. There's energy storage systems, because the generation tends to be renewable and intermittent. So you need some kind of energy storage system to mitigate the ups and downs of that. And then you may or may not have a utility connection because the existing grid is there, it's capitalized, and it's sunk capital. It'll continue to exist for quite a period of time. And then in the middle of it all is the brains, the microgrid controller. Where we focus is the energy storage part and the microgrid controller, because they're really the two key components that the two most critical components that makes the microgrid scalable and adaptable to the customers in the mid-market. So in our solution, just looking a little deeper, we take energy from whatever source it comes from, whether that is the grid or the renewables or biomass or wherever it might come from. And then we bring it into our hardware systems, our battery energy storage systems, and then have software to manipulate the energy that's stored in the battery energy system. And what our customers use our products for are peak shaving. That's buying power overnight when it's very cheap, and then using it during the day when the grid is very stressed and the price of energy can be quite high. You just pull from the battery instead, and so you're saving a lot of money just by doing that. You're also reducing the need for peak power plants, so it has a very good green component, because if everybody did this, a lot of those peak plants are natural gas based. They would not need to come on, so you eliminate a lot of carbon. EV charger support. EV chargers are hard to implement because the local grids don't have the capacity just in your neighborhood or wherever your industrial park is to support a lot of EV chargers. They're quite energy intensive when they're operating. So the energy storage can mitigate that and smooth it out and make it possible to develop EV chargers. We're transportable power. We're actually working with a project right now with a partner in Illinois that you'll see a lot more of or hear a lot more about in terms of bringing a portable EV charging station that is completely self-contained with solar energy storage controls and EV chargers to wherever you want it to go. It's completely off grid. And so that'll enable remote locations and things like summer camps and things like that to be able to get EV chargers. And then finally, people use it to go off diesel, off grid in their operations, reduce their use of diesel, or go completely off the grid in certain locations. And our solution, when we look at it, is that you save, we're compared to any of our competitors who do battery energy storage like Tesla or LG or Samsung, the big players. We're about a third, 30% cheaper. We deploy much faster because we bring both the hardware and the software components. So we're about twice as fast on deployment, and we just can fit in much better to these commercial, institutional, industrial customers, and that's why we're having a lot of success, and that's been our focus. So we've had a good number of successes. Again, just reiterating sort of where the markets are: the utility, commercial, industrial, and residential, and we play in this market. If you look at it from an energy content point of view, our energy storage systems generally are 100 kilowatt hour, and we go up to about 10 megawatt hour. And when you get beyond that, you're into the utility market, and that's where all the bigger players want to be. And so we don't go there. Just deepening a little bit deeper dive into our technology. Our secret sauce, as Vienna Chow is the founder of the company. And she unfortunately couldn't present today, but she calls this our secret sauce. I like that title on that slide. We have our energy storage systems, which are largely composed of batteries, lithium ion phosphate batteries, with a bunch of controls and so on. And that's what this My Control unit is. That's all the software that operates within the container, all the environmental controls, the HVAC, the safety, the fire suppression, all of those things. And then we have 3 other bundles of software that we've developed in a stack. We have a monitoring program that lets you access and operate the system remotely. We track every battery cell. We measure every second of the day, all year round, 24/7. And we track all that data in very large databases. So we can see the whole history of the system and know if there's a battery cell that's faulty or causing problems and what to do about it. We have a Microgrid operator, which is the actual algorithms that you want to use the energy storage for, whether it's peak shaving or EV charging, or you want to limit things. There's a whole algorithm that's implemented here. We have a library of them, so our customers can just pick the ones they want. And finally, we have a simulator tool, which is used before the customer buys the product to actually size the optimal sizing. And that's one of our strengths, is that we can size extremely tightly to what the customer's needs are. A lot of our competitors will use building blocks of say 250 kilowatt hours. And so you get somebody needing 384. And if they use that competitor, they're going to buy 500 kilowatt hours, which is, very expensive and way overbuilt for their needs. So we are able, that's why customers like us. We can tell you. So we take the simulator, we get it, we get everything to the site and installed and up and running, usually in less than 6 months. So that gives us a very fast time to market. And what happens by our approach of bringing everything in that bundle of software and hardware is that we drive down the cost and we shorten the time. And what happens in a standard project is you have about 7 or 8 major phases. I think everybody here that's done a project knows this. You start with a developer, a design engineer, and then you have a bunch of procurement and integration that goes on in the middle here for all the different parts and making it all fit together. And then finally, you have the operating part. We bring all of that down to just 4 steps, where we bring in the middle here, we eliminate a lot of these steps. And even on the software for operation, we bring it forward in here. It's already installed. And then you have just the developer comes up with the idea, design engineer specs it out, and they put in our stuff, and then the installation contractor installs them and you're running. So that shortens the time and the cost of getting the system up and running. This is where we have systems installed already. And the main takeaway from this slide is that everything you see on here has been done under conditions. We started the company in 2018. So you can imagine what an astute time that was to start selling. But we've installed systems around the world, all under conditions of COVID, inflation, supply chain shortages, shipping crises, and war. And if you just named a list of potential problems. It's been out there for us, but we've done all of this in that time frame. We're now in 4 Caribbean countries: Canada, US, UK, and China. We've sold systems as well. Just in terms of working with partners, our model is to use channel partners. So we look for firms that can bring us anywhere from $1 to $3 million a year of projects. A typical project runs about $300,000 to us. So we're looking for them to do 3, 4, or 5 projects a year with us, one every few months. And so these channel partners are engineering, procurement, construction firms who actually build the projects, or equipment providers who would see us as an adjunct to their equipment that they're providing. So we've signed a number of these already. We've got about 10 of them in place, and we hope to ultimately end up with about 50 or 60 channel partners that'll give us that business. And Day and Night is in Illinois. I've highlighted here in Collinsville, and they are the exclusive best promoter within the National Electrical Contractors Association. That's 5,000 members of unionized electrical contractors. And they also are the exclusive solar panel promoter within that group as well. So they're a fantastic partner for us, and we have an awful lot of things going on with them. And then we have a bunch of other major corporations. Unfortunately, some of them won't allow us to disclose their names publicly, so we have to mark them as confidential. But so even Fortune 100 companies are partnered with us on selling our equipment alongside their equipment. And so I'll stop there. I'm not sure what questions might arise, so I've left it open so you can take the conversation any direction you'd like to go.
Great. Thank you so much, Dennis. I'd like to invite all our presenters now to turn their cameras back on for some discussion. I'd also like to take this opportunity to welcome Rowan Merzello, the technical engineer at Evercloak, to join us for the Q&A. Katie is going to continue checking the Q&A and chat for questions, so please continue to place your comments and questions in there as well as we go through this conversation, and we'll try to address all of them. I'll go ahead and get started with a couple questions to kick off the conversation. And the first I'd like to pose to each company: what advice do you have for building owners who may be reluctant to take the risk of being an early adapter with new technology?
Just go for it. No. I think for CleanO2 specifically, but I'm sure for the others as well, we really want success for these projects, right? So it doesn't serve us to just let sell something and let the building owner figure it out. So we will be working with you every step of the way, just so that we can ensure that this is good and successful, that everybody looks good at the end of the day. So we know it's a little bit scary to try to adopt new technologies, and especially in buildings, which are very expensive and your margins are quite small. So yes, we're willing to work with you.
Thanks, Warren. Dennis or Rowan, do you have any additional comments?
I'll put my hand up. So for the building owners, there's tremendous paybacks as we do in our pre-sales analysis for a lot of them. It's really about understanding when we integrate the solar, we need to figure out sort of where we're going to put it. Is it going to go on the roof? Do they have land around the facility, or how we're going to integrate that? But if you're going to bring EV chargers into your building or your parking lot, that has a significant impact on your building electrical. And so energy storage can help with getting that in at a much lower cost than, say, having to redo all your electrical. So if that's been deterring you, the cost of that to put EV charging in, you're going to need to support that. It's coming everywhere. And it's being mandated in a lot of places where you must have, say, 25% of your parking spots with EV chargers, et cetera, et cetera. That's all happening everywhere. So that we can bring that and we can work with you to figure out sort of the economics to make it work. Yeah, so it's worth investigating.
Thanks, Dennis. Rowan, any comments?
Yeah, I would like to say that for business owners, especially, just sort of understanding how the technology works, what it sort of brings in. You know, if we sort of have something which can be easily retrofitted, what is those overall capital costs that's involved, and at the end of the day, how much you're actually sort of saving. So, you know, we are in this together. We're working towards a greener future. So that's what we need to keep in mind. Yeah.
Rowan, I'll stay with you. What are you finding is your biggest challenge right now? What's keeping you up at night?
Well, the main thing is we're just starting up with this whole, like, a new different area of membrane development. So it's, you know, just racking in this number of hours and trying to get a lot more pilot projects out, discover and sort of see how they actually perform at the field, and, you know, the whole scaling up part of it, right? Because you just start off in the lab, you're just working out with this new technology. You want to make sure that when you're scaling, you're able to sort of translate all that information from a small size and take it up to a larger size, and making sure that you can sort of retain the same performance. So I would say that's the key. The main thing that's keeping me up at night, essentially.
Yeah. Warren, how about for you and your team?
You know, we're kind of in the scale up right now, so that's keeping us up. So if we get an order for 1,000 units, how do we do that? The thing that kept us up previously was this is a new class of heating and ventilation equipment. So doing on-site gas processing in a mechanical room is hard for local authorities having jurisdiction. So safety codes officials for cities, it's hard for them to get their head around, and it was easier for them to just say, no, you can't do that. So it's been a year and a little bit of just kind of patiently hand holding with all the people who have to touch a project to get something into a building. And we're getting through it. So actually getting successful machines out in the field in buildings, and they're operating safely and doing the thing that we want them to do. So yeah, we're kind of coming out of the nervous stage and into the very, very exciting stage. So that's cool.
Good. And Dennis, I'll kick it over to you. I know you addressed COVID was a challenge, but what about right now? What's the new challenges on the horizon for you?
For us, the biggest challenge is we're in scale up mode as we grow forward here. So the biggest challenges for us have been simply just fulfilling orders. The supply chain is still very tight on a lot of components. There's shortages and things are hard to get. So just keeping to our schedules and getting systems out the door of the factory and onto the thing. The other part is just the capital required to grow the business at scale. the working capital. These systems are quite capital intensive, and we've got to fund some of that during the manufacturing process. So that's the other challenge. With the capital markets the way they are right now, it's the discussions are a lot, I would say, more in the vein of just sort of friendly or polite conversation, but the answer was no before you started the conversation. But people don't. I don't know the right phrase to use there, but something like that. So those are the two big immediate challenges. And then, of course, there's the whole geopolitical situation, because we use batteries, and batteries are now becoming a strategic item for across the geopolitical scene. So that we are the IRA. I believe you want to talk about IRA a little bit later on. That's the third thing that we think about a lot, as to how to manage our company within that need.
Sure. So as you face these scale up challenges, though, what's driving you? What's keeping you motivated and excited to push through the challenges? Dennis, we'll start with you and work our way back.
Vienna and I, from the outset, had the vision, we want to build a global champion in new energy, and we're relentless in that goal. So we see it as a great thing to do for society in general, for humanity, but also to have a lot of fun, make a difference, leave a legacy. That's kind of what keeps us going.
Great. Warren?
Oh, the problem is large, so we gotta hit it hard, right? So global climate change is a big problem, and we still want to have comfortable buildings and maintain our lifestyles. So yeah, it's a daunting task, but a fun task, right? So that's where we come from.
Great. Rowan?
Yeah, as mentioned, it's the same sort of goal, making sure we can be a sort of disruptor in this whole journey towards building a greener future. So, with the fact that we can sort of target larger, or essentially like a global HVAC market, we want to make sure that we push ourselves to make that difference.
Thanks. Okay, so now I'm going to get to some of the technical questions that the viewers have put into the chat. And the first is for you, Rowan. The question I have is, what is the increase in pressure drop, assuming the air moves through the membrane?
So the way it actually works is the air moves parallel to the membrane. So if you think about it as like a sort of a flat sheet, the air basically just moves over it. So you have a couple of membranes essentially stacked together, and then it depends on the configuration you have, like what is the flow rate you're dealing with. So if you have a certain flow rate that let's say you want to throw in a cross-sectional area of 1 by 1 feet, roughly, you'd have roughly between 0.1 to 0.2 inches of water. So it's not a very huge pressure drop, but it sort of changes depending on how many membranes you want to put together, and like what your design or your system constraints are.
Thanks. And then quick follow-up, how long does the membrane last before it needs to be replaced?
So that's an interesting question, because we are still in the process of doing longevity testing for it. So I think within a period of time, we should be able to sort of tell, what that figure would be. But as of now, we're still in the testing phase.
Sure, understandable. The next question I have is for Warren. Warren, what is the max temp the cold water feeding your unit can be? Is there a max temperature?
Not exactly. So I guess the technical answer is that you want to recover heat into that water. So the maximum temperature is the exhaust temperature in the flue stack. So if the entering water temperature is equal to the gas temperature, then there's no heat transfer. So if we do want to recover heat, then the water temperature has to be lower than the exhaust temperature. So I don't know, in the condensing system, that's probably 50 degrees Celsius. But I don't know, in a non-condensing system, you have 80 degrees Celsius water coming back, or 60 degrees Celsius water coming back. What's that, 140 Fahrenheit?
Great. Thanks, Warren. And then Dennis, I have a question for you. A specific one is, what if we have 5 EVs now in our garage, but in 10 years, we'll have 200 EVs parked in our garage? Is this a scenario that you could help address?
Great question, and yes, that's one that a lot of building owners think about. So, a single EV charger depends whether it's a level 2 kind of charger, which takes about generally 12 hours or so to fill a car up, versus a fast DC charger, which can do it in 30 minutes or less. So you see these different types of chargers. The energy level is really high. So if you want to do 200 fast DC chargers, that is a huge amount of energy, especially if they're all operating at the same time. Our system can do that. Of course, you'll need a bigger system for more chargers, but the systems are actually easily scalable. You can just plug one onto the next one. So you can start with a small one to cover the chargers you have, and then add on as you add more chargers. So you don't have to put up all the capital at once. So it can be done. It can support it. And you might even want to integrate some solar energy on your building so that you can sell that power to the cars and make money from your system.
Thanks. Back to you, Rowan. Is there an ideal building size for your systems right now as the technology stands?
Not exactly. We still haven't sort of predicted that one yet, but we are sort of targeting the commercial area. That sort of makes sense. I would say, yeah, anything between 1,000 to 2,000 units probably in a commercial sort of tower residential building. But I don't exactly have a figure right now.
Okay. And then another question for you too is this essentially separate, sensible, and latent cooling, SSLC? And what are you using as your liquid desiccant? Are you doing anything with the heat of absorption? And how are you regenerating the desiccant? That was one group question altogether.
Yeah, so first, we don't use any sort of desiccant material in our system. We don't use any liquid desiccants in it. It's just a membrane-based dehumidification. So we essentially we create a sort of low pressure, and then that's your sort of driving force across the membrane. So it just directly extracts the water vapor, and then it's just exhausted out to the atmosphere. You don't need any sort of regenerative process. It's different from how liquid desiccant systems work.
Great, thanks. Warren, back to you. Will the CarbonX 4.0 have a waste heat recovery aspect? If so, how effective will it be when pairing with a condensing unit where the flue gas is less than 140 degrees Fahrenheit? With 50% carbon capture rate, it doesn't seem like waste heat recovery will be as important for the ROI.
Yeah, there's a lot of tricky technical questions in there, but yes, you're right. So to get a condensing boiler to condense, you have to be returning water at less than the condensing temperature. So if it takes heat out of the flue gases already, and if our part of our machine recovers waste heat from the flue gases, then aren't we kind of stealing from this part and paying over there? Kind of. The condensing boiler already condenses the flue gases down to 140 degrees Fahrenheit. So we have 140 degrees Fahrenheit to play with, and we just have to find some place that's colder than that, a lower temperature that we can park some energy. And we can do that with swimming pools or in slab heating systems, or like unit heaters that are heating a garbage room in your building. Or there's a load of different applications that are low temperature, and we'll always have enough energy to recover some heat out of that flue gas. The other thing with our machine, the reaction between potassium hydroxide and carbon dioxide is exothermic, so it gives off a little bit of heat. And we get to capitalize on that waste heat because there's always going to be carbon dioxide in the flue gases, regardless of whether it's condensing or not condensing. So the flue gases come to us at whatever temperature is given, and then we add some heat in our reaction, and then we send that to our heat exchanger and recover that heat as well. So there's always some energy to be recovered.
And to add on to that, do you have the numbers of what a typical efficiency improvement would be for, say, an 80% efficient boiler system?
It is a bit tricky. So our system, we have a one size fits all system. So it does 8 metric tons in a year or 7 metric tons in a year. And it could be hooked to a massive boiler. So our 8 tons might look pretty small compared to your 3,000 tons of emissions, or it could be hooked to small boiler, and our 8 tons look amazing. So a percentage is hard to come up with unless we know something about the boiler itself that we're attached to.
Thanks, Warren. All right, Dennis, I'll come back to you now. There's a couple questions here. One being, do you know where microgrids are being developed in Illinois? And do you happen to know who the developers are?
In Illinois right now, we're not actively doing any ourselves. And I'm not sure who's doing. Actually, the answer to that is I don't know right now. I'd have to do some digging around to gather that information.
No problem. And then a follow-up question is, how will the batteries be managed in the circular economies that are emerging? And how will circular economies manage oscillating circular economies that are replaced by superior circular economies?
Okay, so that's a trap question. The answers that I would see it. So the circular economy, the batteries are very recyclable when you break them down in their components, and there are companies like Li-Cycle that are out there already setting up the infrastructure to do that. To date, the battery industry, whether it's EVs or whatever, hasn't been around that long, and the batteries have life cycles of 10 to 25 years. So you haven't seen a huge cycling yet of the materials, but they do recycle very well for the most part. And then the question becomes, what happens when the lithium batteries get replaced with something else? Because technology is always changing. I think that's the second part of the question. What happens? Well, at that point, that'll be for the future to decide. We can't really say much about that right now. It'll all depend on where they go. Do they want the lithium still? Is it some other lithium form, or is it a hydrogen kind of idea, or what is it that's replacing it? And so and what would be the value of the materials left in the batteries that are still out there in the world? That would be to be determined at some other time.
Sure. Thanks, Dennis. Warren, another one for you. For the boiler flue carbon capture, what are the plans to use the salt precipitate? And will these uses limit or prevent reintroduction of carbon back into the atmosphere?
There's a whole value chain to the value of potassium carbonate, and it's industrially produced right now. So I guess I can answer another question that I saw there too. So what goes into manufacturing the input chemicals, and do we have greenhouse gas penalties up front? And the answer is yes. So to manufacture potassium hydroxide, the material that we put in to the machine, you take salt, potassium chloride, that's a mineable resource, and you electrolyze that potassium chloride, and you get hydrogen gas, chlorine gas, and potassium hydroxide. And then you send the potassium hydroxide to another plant, and you burn natural gas for the carbon dioxide, and you bubble the carbon dioxide through the solution, and potassium carbonate is the product. And then you send the potassium carbonate to industry. We do the same process. So take potassium hydroxide, put it in our machine, and then recover potassium carbonate, except we use somebody else's already burned natural gas. So we capitalize on a waste stream of carbon dioxide. So if we take a penalty on the upfront side for the manufacture of the potassium hydroxide, then we get the benefit of manufacturing potassium carbonate that has a higher greenhouse gas intensity. So we're always coming out ahead. Then I forgot the question. Okay. Oh, the value. Okay. So the reason we make soap is that it's a nice scalable product for us, and it has a nice high value for us too. So you can sell a little bit of potassium carbonate as an ingredient in the soap for many thousands of dollars per ton. So that's great. And then if we have a more bulk product like fertilizer, for example, so potassium carbonate can go into fertilizer if we have enough of it. And we've talked to the fertilizer manufacturers, and they're very interested, but they need train loads of potassium carbonate, which we can get to if we have more machines out in the field. It's a scaling problem. So yes, we can fill a train with potassium carbonate if we have thousands of carbon capture machines. And we'd love to sell thousands of carbon capture machines, but that takes the personnel to do that, which we'd love to get to. So look for us in 2024. But yeah, eventually we'll sell soap and fertilizer and glass cleanser and drilling mud lubricant and on and on, and then finally into just the bulk chemicals industry, which has the lowest value for us. But yes, there's a big value chain that we can take advantage of.
Terrific. Dennis, here's the IRA question. We're just curious if and how the IRA bill will impact your go-to-market strategy. So I'll let you start, and then Warren and Rowan, if you want to address it as well, please chime in.
Yeah. Go-to-market is definitely impacted by IRA, the Buy America provisions and so on. So we had originally, we were building a North American supply chain. We were actually looking, right now we fabricate mostly in China. That's where the batteries are and have been for a long time. But North America is starting to come on stream with batteries. So we were looking at bringing production here to serve the Americas. But now that plan has changed in terms of where we're going to locate and the scale at which we need to do it and the speed at which we need to do it. Because the IRA is accelerating the demand for the products. And the tax credits in the program are quite strong. And so you can get up to 60% tax credit on your investment if you do it properly. There's sort of 30% baseline tax credit, and then there's another 30 of extra credits you can earn by using union labor, for instance, and some other things. So yeah, it's pushing us in that direction. So we're currently looking at several sites in the U.S. to build a factory, and then so it's forcing us to move in that direction, be able to supply the places that will require us to have a U.S. presence and U.S. content, because that's about a good chunk of the market. So we don't want to limit ourselves.
Rowan, how about you?
I feel like Evelyn would probably have a better answer for this.
Sure.
Yeah.
Warren, any comments? Otherwise, we can go to the next question.
I think Warren's muted.
Warren, yeah. Thanks, Dennis.
Now I'm unmuted.
You're back.
There we go. Such a modern problem. So it hasn't been a problem quite yet, just because we are manufacturing something that is kind of new to the entire heating sector. So there is no American option of buying this, but we are in discussions with some boiler manufacturers down in the United States, and the boiler manufacturers themselves are under pressure in a carbon constrained world. So natural gas utilities and the boiler manufacturers and the heating industry in general is moving to lower carbon options. And if you are a carbon-based fuel supplier, then you're you're in trouble. So all these players have they have political clout, and they have like a demand for better performing options in greenhouse gas emissions. And we are talking about manufacturing in the local jurisdiction. So be that Japan or the United States or Canada or wherever we go, basically. And we don't have a big manufacturing facility here in Canada either. So moving somewhere and taking advantage of other established companies that have manufacturing, that would be great for us.
Great, thanks everybody. Here's a question for the group too. We have a couple of sustainable consultants listening today, and they're wondering how they can get involved with each of you and your companies, understanding that there may be some requirements to bring in a certain amount of deals into the pipeline per year. If you could just address how people can get involved with you, I know that would be benefit for not only consultants, but potentially customers too. Rowan, why don't you go ahead and get started on this one?
Yeah, I guess the best way, like if you can sort of, like if you go to our website, Evercloak, I'm sure you can get a lot of information there on what we do, and maybe just shooting us an email to reach out and see what we can offer. We definitely want to know who's, or get some sort of expertise in the HVAC space, and then see what exactly you're looking for, because we're on the whole sort of dehumidification thing. That's definitely one part of the market that we want to target. So essentially sort of building that relationship and seeing how best we can work with different people, and what would be the most suitable way to sort of get our product out there, and essentially build that pathway towards a larger commercialization scale. Yeah.
Thanks, Rowan. Warren?
Sell. So so that's basically what we need is more machines out in the world and making money off of those machines. So if you can help us sell machines, then great. Come and talk to CleanO2.
Great.
And
Dennis?
customers.
Oh, thanks.
Customers. If you're a building owner, then come and talk to us too.
Yeah.
Can I do a quick show and tell?
Sure.
The simplest way to answer the question, if you go on our website, that's TROES, TROES, Corp, CORP.com. There's an About button. If you click on it and it says Contact, request a quote, become an agent, become an investor. You can just go there and fill out the form. If you go on the Become an Agent, a simple form pops up and you just put in some information. This is all automated on the back end, and will come to our head of agent management. We have a person who's in charge of agent relationships, and they will contact you very quickly after you put the information in, and then take the discussion from there.
Thanks, Dennis. All right, so here's our last question. Just basically, is there anything that we haven't been able to ask or address that you want to make sure listeners on today's call leave the webinar with? And if not, and you'd like to share your own origin story of joining your company, you have the option to share that as well. So you can pick, and then we'll wrap it up here in just a few minutes. Dennis, why don't we start with you?
I think that's something I left out of the presentation, because it's hard to know exactly what to put in these settings. The microgrid side, where we're seeing particular strength, especially in the Caribbean, the reason we have so much Caribbean business is where people have existing diesel generators or natural gas generators. We're also seeing that in farms, farming communities. And we combine solar plus their existing carbon generators, plus our energy storage and our control systems, and give them a very robust solution. And what happens when we do that is the solar is not reliable enough to take them completely off grid or off the diesel generator, but we reduce the consumption of the fuel by anywhere from 30 to 70%, depending on how they use it and what they do, because we can run we then control the generator. We run most of the power from the solar, but when we need some, we take it from the generator. So we really reduce the gas. It could be a natural gas generator as well. In the Caribbean, everybody runs on diesel generators, and our solution has become extremely popular because of that. That's why we've had so much success. But that's actually, if you if you think about diesel generators, this is a great way to minimize the amount of fuel that they're using and reduce the carbon footprint of that diesel generator.
Thanks, Dennis. All right, Rowan, why don't you go ahead?
Well, the one thing that sort of drew me towards EverQuote is nanotechnology. I feel it's a very exciting avenue, especially, with all the development with graphene oxide and, its various potentials, and, sort of taking that technology, making these flat sheet membranes and then trying to employ them in various applications, from, let's say, the dehumidification we have to building HVAC and lots of other potentials out there. I think we can definitely make a huge impact, and that's what we're sort of hoping to see. Our vision is to sort of build a better future. We can, if we can sort of make that change, and especially considering that global HVAC is one of the most demanding energy resources on energy infrastructure, you're saving at least hundreds of thousands of tons of carbon dioxide that's emitted. And I feel if we can sort of, make that change, it's a stepping stone to a better future. So that's my take.
Thanks, Rowan. Warren?
I guess one thing to keep in mind is that buildings are extremely long-lived assets, and changing a building once it's constructed and occupied is really tough. So so the fuel choices that we have are somewhat baked in as soon as the building starts construction. And we like natural gas because it's energy dense and does what we want it, and is relatively cheap. So we don't like the emissions from that. We like the cost and efficiency. We don't like the emissions. So what do you do as a building owner? And CleanO2 has come up with at least one thing that you can do, one extra tool that you can put in your toolkit. And natural gas, when it enters the building, does one of two things: space heating or water heating. Electricity does this whole spectrum of things, can turn from communications all the way to like low grade heat. So all, like do you want to abandon your natural gas heating plant and go to something else? I think we have at least one extra solution for you.
Great. Thank you, Warren, Dennis, and Rowan. We've now reached the end of today's session. Thank you formally to Illinois Green, the Consulate General of Canada, today's companies, and all of you for joining. Illinois Green will be sending a follow-up email later this week with the recording and contact information for all our speakers today. We hope to see you at our next event, the April Member Breakfast on April 19th from 8 to 9 a.m. at 180 North LaSalle. For more details, please follow us on Instagram at IL Green Alliance or visit our website at illinoisgreenalliance.org. Thank you again, everyone, and have a great day.